So, question 11. So we've got the railway. So we've got the train basically at B travelling right to left. Okay, so along this road at a speed of 25 meters per second, and similarly we've got a car travelling upwards from A towards O at a speed of 20 meters per second. And we're being asked for one to find expressions for the distance OP and OQ as a function of t. So let's start off with the OP. So we've basically got this car travelling along here at 20 meters per second. So when t is 1, it will have travelled 20 meters. When t is 2, it will have travelled 40 meters and what have you in this direction. So basically the distance that it's gone, so basically O to P is going to be 100 take away 20 times how many seconds have passed, so 20 times t. Okay, so let's just go over that again. The distance OP is going to be 100 take away how many lots of 20s we've gone backwards in this direction. So for example, if we've been travelling for 2 seconds, that distance would be 60, because we would have 100 take away 2 lots of 20, which is 40, giving us 60. Similarly, the distance OQ equals the full distance from O to B, 400, less 25 lots of whatever t is. Again, let's think about when, say, t was 4. After 4 seconds, we'd have gone 4 seconds worth along here, 4 lots of 25, which would be 100. 400 take away 100 would be 300. So these are two expressions for OP and OQ as functions of t. Now for part 2, the distance between the car and the train at times t is x meters. That's this length here from P to Q, which is x. And what we've got here then is just Pythagoras. So we've got OP squared plus OQ squared equals x squared, with OP being this and OQ being this. So we've got 100 minus 20t all squared plus 400 minus 25t all squared equaling x squared. So then multiply out the brackets and gather like terms, we get x squared being this. Now for part 3, we're being asked to differentiate this and find the time at which x squared is a minimum. So we're going to differentiate x squared. So differentiating x squared with respect to t, we get minus 24,000, and obviously with this term here multiplied by 2, reduce the power by 1, we're going to get 2050t. So our differential is minus 24,000 plus 2050t, and at a minimum that's going to equal 0. So we're solving this equaling 0. So adding 2050t to both sides, then dividing by 2050, we get t being 480 over 41. So that's the time when x squared is a minimum. So taking that time and substituting it into our x squared equation, so substituting it into this, I get this. That gives me x squared being 29,412, so x being 171.79 when I've square rooted, which is 172 meters to 3 sig figs. Now for part 4, show that the car passes point O before the train does. Well, the car is travelling at 20 meters per second, okay, and it's got to travel a total distance of 100 meters, so the car's going to get there in 5 seconds. The train has got 400 meters to go and is travelling at 25 meters per second, so that's going to take 16 seconds. So we can see that the car passes point O before the train, because the car passes after 5 seconds, whereas the train passes after 16 seconds.